All right, Geometry Honors. Second part of lesson 4.5, we're looking at angle side angle and angle side as methods for proving triangles are congruent. And last thing we did was we did a flow proof, and I actually really like flow proofs because, well, you can kind of work backwards in a very precise way. I can see where my result is, and it was angle side. I can then see exactly where I said the pair of sides and the pairs of angles are the same. I can work my way backwards. It's just a nice way to present a proof. All right, so let's flip it over, see what's on the back here. Example 3 says, write the third congruence that is needed to prove triangle ABC is congruent to triangle DEF by the given postulate or theorem. And we've got A, B, C, D, and they're all going to be using the same picture, so I'm going to draw kind of lightly on here. Well, for the first situation, we're given AB is congruent to DE. Go ahead and mark that on the picture. And CA is congruent to FD. And then it says using the SAS congruence postulate. Well, if we're going to use the SAS congruence postulate to prove that the triangles are congruent, the angle that we're going to have to know has to be the included angle between the two sides. So we're going to have to know that angle A is, angle A is congruent to angle D. And that's how you work these out. So if this was in class, I would encourage you to, well, yeah, I mean, we're on a video here. Why don't you pause the video and maybe try these others and then unpause it and see if we agree. Okay, so for part B, we still know that A, B, and D, E are congruent, but then we also are told some perpendicular lines. And it turns out that if you know the lines are perpendicular, you know that you've got some right angles at BCCA and EFFD at that intersection. So we've got those right angles. And it says, what else would we need to know to use the hypotenuse leg congruence theorem? Well, so far, we've got a right triangle, so that's good. But then we've got the side that's across from the right angle, and that's the hypotenuse. So we just need to know a congruence relationship with some legs. And we've got some options. You can either do these vertical legs here, or you could do these more flat horizontal legs. It doesn't matter. Either or is fine. So you can either say BC, segment BC is congruent to segment EF, and you'd be done. Or you could choose to say AC is congruent to DF. That would be enough. Part C, we are told again that AB is congruent to DE. But this time we're told that angle B and angle E match. And what else would we need to know to prove these triangles are congruent using AAS? Well, to be AAS, the other angle needs to be such that the side that we know is congruent with another is not included, is not between the two angles. So I can't go here, I have to go here. I'm gonna have to know that angle C is congruent to angle F. And finally on D, hey, look, we got that again. And so we start out the same way. But this time they want us to do ASA. And for ASA, the sides need to be the included sides. with the two angles. So we would need to know that angle A is congruent to angle D. All right, example 4. We're going to do another flow proof. And let's start out with our given. So draw a box. Angle CBF is congruent to angle CDF. Segment BF is congruent to segment FD. Our justification, our reason is given. Our reason is given, and that's where we're going to start. Anytime we're given some congruence relationships, go ahead and mark them on the picture. CBF is right there. CDF is right there. BF is right there. FD is right there. And we're trying to prove that ABF is congruent to EDF. Now, what's a little bit maybe frustrating about this is the angles they tell us are congruent are not interior angles, are they? They're exterior angles for those smaller triangles. But my gut's telling me, gosh, because this appears to be a straight line, right? That makes these angles supplementary, and if we know the same pair of angles are congruent, then I would think that the supplements would also have to be congruent. And it turns out we've actually learned something, a theorem that tells us that. So here's what we're going to do. We're going to say, we're going to start off by saying angle CBF and angle FBA are supplementary. We're also going to say in the same statement box, angle CDF and angle FDE are supplementary as well. Now, how we know that is because of the picture. They're a linear pair, and you can either say definition of a linear pair, or you can say linear pair postulate. We actually learned it as linear pair postulate, but I had some students argue, well, isn't it kind of like the definition of a linear pair is the angles, and then they have those opposite rays and stuff like that, and they have to add up to 180, and so all right, that works. Technically it's linear pair postulate, but I would accept definition of a linear pair as well. Okay, this, knowing that those angles are congruent, combined with knowing some other angles are supplementary, means that we're going to be able to say that angle ABF is congruent to angle EDF. And the reason we can say that is because they are supplementary to two congruent angles. It's called the congruent supplements theorem. Now, notice I didn't draw any arrows to this statement here. That was based off the picture. It didn't come from these statements. But now the congruent supplements theorem, it required us to know that some angles were congruent, and it required us to know that some angles were supplementary. So it's the result of those two reasons right there. Okay, so after using the congruent supplements theorem, we know that these two angles are the same. And so far we have angle side, or side angle. We need to know one other set of congruents in order to be able to prove these triangles are congruent. And I see it right here. We have angle BFA is congruent to angle DFE. And why am I so sure? Because they are vertical angles. Technically, it's the vertical angles congruence theorem. But if you say just vertical angles, I'm down with it. I'm totally down with it. And we got that just from the picture. So now if you notice from our diagram, since we've marked everything, I can see that I can say these triangles are congruent by ASA. So I'm going to go ahead and finish this up. Triangle ABF is congruent to triangle EDF. And my justification is angle side angle congruence postulate. Or you can just say angle side angle. I'm totally cool with that. Now we have to draw arrows to what led us to think this. We knew this because we had two sets of angles congruent. And we need to, we also knew a side that it was included with them was congruent. Oh, there it is way up there. Because of that right there. And boom, you've got yourself a flow proof showing that the triangles are congruent. Now, flow proofs can look pretty different depending on where you draw things. For example, I worked this proof out another time and it looked like this. But if you trace everything back, you'll see, oh yeah, it's the same justifications, the same reasoning. It just looks different. And actually, I'll cheat a little bit. There's your practice. Have a good day.